How to balance a chemical equation. Before we proceed to the steps on how to balance a chemical equation, let's define what is a chemical reaction and a chemical equation. Basically, a chemical reaction is a process in which a substance is converted into one or more new substances. When a person eats breakfast, chemical reactions begin in the mouth as the salivary amylase acts on the food. Then reaction continues in the stomach, where digestive enzymes break down food into compounds essential for the body, and then some other significant reactions occur to absorb nutrients and eliminate the waste products. Chemists want to understand chemical reaction. That's why chemical equation is used to show what happens during a chemical reaction. A chemical equation is represented by this convention. For example, B plus C produces D. The plus sign means B reacts with C, and the arrow means that D is produced from the reaction. The left side of the equation is the reactant side, while the right side is the product side. One good example is the reaction of hydrogen gas and oxygen to form water. This chemical equation is not balanced. As you can see, there are 2 atoms of oxygen in the reactant side, while only 1 atom in the product side. To obey the law of conservation of mass, there must be the same number of atoms on both sides of the equation. We can balance the chemical equation by placing coefficients in front of the compounds or atoms. In this case, all coefficients are equal to 1, but we don't actually place 1. Take note that we are only allowed to change the coefficients, but not the subscripts. The subscripts are the numbers within the formulas. Changing the subscript will change the identity of the compound or substance, thus it will change the equation into a different reaction. The first thing to do is look how many atoms of each element are present in the reactant and product side. 2 hydrogen atoms are in the reactant side. There are also 2 hydrogen atoms in the product side. There are 2 atoms of oxygen in the reactant side, but only 1 oxygen atom in the product side. The next step is to manipulate the coefficient to balance the equation. We can place 2 in front of water. Now, there's 2 oxygen atoms on both sides. This time, 2 hydrogen atoms are multiplied by 2, thus equal to 4. We can place 2 in front of hydrogen gas to make it equal to 4. Now, 4 hydrogen atoms are present in both sides of the equation. The last step is to check the balanced equation to ensure that there are same number of atoms in each element on both sides of the equation. The chemical equation is now balanced.